Hello Professor, I am Yogesh Nepane and this is my video presentation for Azure Machine Learning part 1. So you can see this is the overall pipeline for this part of assignment. Let me describe each steps that I followed. So I started with importing dataset, and then I select the relevant columns by excluding normalized losses, and the next step was to clean the missing data, which was then followed by selecting feature selection, where I selected the columns like make wheelbase, engine size, horsepower, peak RPM, highway mileage, price, and body style. Then I splitted the data into 75 by 25 of ratio for training and test datasets, and then I chose linear regression as this is suitable for this type of dataset. And then I trained the model, where I selected price column as our target variable, and then I use score model to see how well our model perform, and the evaluate model let us help to see the result. So let me quickly run this model. Mm, just give me a sec. So let's see the final result of this assignment. Preview data. So here you can see the result for MAE, RMS, RSE, RAE, and coefficient of determination. So that's all for the part 1. Now let me begin with part 2. So here you can see the overall pipeline for the part 2 of assignment. Now let me begin with each step and its brief description. So the first step is here importing dataset, and this dataset contains information on credit applicants, including attributes like credit history, loan amount, employment status, and many more. So the second step is metadata. This node ensures that the data type of various columns are correctly defined, and also it involves renaming columns. So here you can see the name of new columns. And after this I have this split data node, which divides the dataset into training and testing sets with the ratio 0.5. After this I have these two nodes which runs custom R script for additional data processing, and this script ensures that the dataset contains at least 21 columns, and this script will stop execution if the requirement isn't met. So for the next data transformation, here I have this normalized data node, which is using transformation method 10, and it's also transforming all the numerical columns except the credit risk. And this normalization is especially important for machine learning models like support vector machine. So let's go with the model selection and training. Here I have first model, which is two class boosted decision tree. So this is a powerful classification model that uses boosting to improve performance, and boosting trains multiple weak decision tree and combines them to create a strong predictive model. And this node is training this boosted decision tree using the transformed dataset. And similarly, here is one more model, two class support vector machine. So this is designed for binary classification. Here you can see all the parameters, and this node is training this model. So after training the model, we have this score model nodes for each of the machine learning models. So this score modeling, so after training, the model predicts credit risks for the test data set, and scoring step applies the trained model to new and unseen data to generate prediction. So this prediction will be used on this evaluate model node, which will compare the scores from this model and this model. So let me show you the compared visualized data. Here you can see the first ROC curve. This plots true positive rate against the false positive rate. The higher curve means better performance. Similarly, this precision recall curve shows the precision positive predicted value versus the recall sensitivity. And similarly, this lift curve measures how well the model performed. So, and the here the confusion matrix, so you can see the overall result. So that's everything for this part 2. Thank you, Professor.